Good morning. Today we're going to talk a little bit about Lesson 5.6, Triangle Congruence. And today's objectives, we're going to determine if triangles are congruent by using the following 5 methods: side, 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 angle, side, angle, 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 side, and hypotenuse leg. This actually references about 3 sections in your book, and they can be found on page 222 through 250. So if you have questions or want additional information, you can always look there. All right, so there's 5 methods of proving triangles congruent, and we're just going to throw all 5 of them at you, and then we're going to spend some time in class today and over the course of the next few days just using these methods to determine if 2 triangles are congruent. And then later on in the chapter, we will use these methods to actually write a formal proof that triangles are congruent. So side, side, side. So as you have gathered by now, the S's stand for side and the A's stand for angle. So if we have the side, side, side method, and you come over here and you look at the pictures on the right, you will notice not only do we have 1 or 2, but all 3 sides of one triangle are congruent to all 3 sides of another triangle. That is the side, side, side method. Now, it's the easiest one. Going on to side, angle, side. If you will look right here at this A, this angle is between the 2 S's. So it's between the 2 sides. If you look over here at this angle in this picture and this angle in this picture, you will notice that it is located between the 2 sides of the triangle. So when we have side, angle, side, that means that we have 2 sides and the included angle. And it's very important that you use the included angle, but 2 sides and the included angle are congruent. So if you noticed in these first 2 methods, we had 3 pieces. Here we had side, 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 and here we had side, angle, side. All right, moving on to hypotenuse leg. So in order to have an hypotenuse, you have to have a right triangle. So a condition of using hypotenuse leg is that one of your triangles is right. And if you look at your picture, we actually have the hypotenuse here, congruent to EF, which is the hypotenuse here. So we must have the hypotenuse of one triangle. And actually only one of the legs has to be congruent. Both pairs of legs do not have to be congruent. As long as one set of the legs are congruent, you are good to go and you can use hypotenuse leg. Now, if you look at hypotenuse leg, you technically only have 2 pieces, but you actually have a third condition that you have to have that right angle. So under no circumstance can you use hypotenuse leg unless you have a right triangle, because without a right triangle, guess what? You're missing the hypotenuse. Okay. The last 2 methods deal with 2 angles and a side, and if you notice the location of the S, here the S is between the angles, and here the S is not between the 2 angles. And if you look at your picture, it's exactly the same. So if you look up here at these first 2 triangles, this side is actually located between, it's like sandwiched between the 2 angles. And if you look at the picture down here below, AC and DF, those 2 sides are actually not between their 2 angles. So that is the difference between angle, side, angle, and angle, angle, side. So the first one, angle, side, angle, you must have 2 angles of one triangle, and the included side must be congruent. Versus angle, angle, side, where you also have 2 angles, except for this time you have the non-included side. So that's the difference between angle, side, angle, and angle, angle, side is the location of the side. So is it between the 2 angles or is it not between the 2 angles? Now, for future reference, you cannot prove triangles are congruent with AAA. We do not have any batteries going on. There is no angle, angle, angle congruence postulate, and we will talk about that a little bit in a future chapter, but there is no way to prove the angles mean anything with congruence. If you think about that for a cool second, if you had an equilateral triangle and then you had a bigger equilateral triangle, these 3 angles are all 60 degrees and these 3 angles are all 60 degrees, yet it's very obvious by my really bad drawing that those triangles are not congruent. The other property we're missing is angle side side. And ironically, in trigonometry right now, that you will take your junior year, we are talking about this week why there's no angle side side property. So right now we're just going to look at our cute little donkey, and remember there's no ASS property in geometry. And 2 years from now, we will revisit this concept. All right, example 1. There are 3 kind of hidden but not hidden things that you need to remember to watch for. We did this earlier in the year with proofs, but we just want to revisit these because it's going to come up and you're going to need these pieces of information to prove your triangle is congruent. So if you look at the first picture, we actually have this side right here in the middle, and it's part of the triangle on the left right here, and it's part of the triangle on the right. And that side is congruent to itself by the reflexive property. So in the reality, if I want to give that a name, I can maybe call that segment AB, and we could say that segment AB is congruent to itself by the reflexive property. The second picture, B, actually shows a set of parallel lines. And if we think about what parallel lines really mean for us, we talked about the magic Z when we talked about parallel lines, and parallel lines form alternate interior angles that are congruent. So you had a property that said, or a theorem that said, if 2 lines are parallel, then alternate interior angles are congruent. So if you look at that picture, we have our 2 pairs of parallel, or our 1 pair of parallel lines, and we have our congruent alternate interior angles. Another very popular thing is vertical angles. So if we look down here at picture 3, we have angle 1 and we have angle 2 over here on the right. So I'm just going to number them for simplicity, and we can say that angle 1 is congruent to angle 2. And we know that because vertical angles are congruent. These are 3 different concepts that you do not have to prove every time, but that you will be using in your proof to help show that triangles are congruent. All right, look at some examples. Okay, number 2A. We are given that AD is congruent to CB and that DC is congruent to BA. To be honest with you, you're crazy if you don't mark up your pictures. So let's mark up our pictures. So here, if I look at this, I have AD. I have CB. I'm going to give them each 1 hash. And then I am going to look and mark that DC is congruent to AB. I have 2 sides of a triangle congruent to 2 sides of another triangle, so I have to determine what else is true about these triangles. So if I want to go for the extra markup, I'm looking right here at DB, and I know that DB is congruent to itself. So DB is congruent to DB. If you look, you have 1 set of congruent sides, 2 sets of congruent sides, 3 sets of congruent sides, which tells us that this is side, side, side. It's as easy as it is. All right, don't overthink this. Just look for the obvious, look for patterns. The same things are going to keep showing up over and over and over again. All right, so the next picture, we have that AB is congruent to CD. We also have that AB is parallel to CD. So if you think back to the previous slide, we talked about parallel lines and we talked about looking for that magic Z. So if we think about what's going on here, I can come in here and I can look at that magic Z right here. And that tells me that this angle down here and this angle down here, I call them the pits of the Z, that they are actually congruent. So I can write that, angle, what is that, ABD, angle ABD is going to be congruent to angle CDB, because if 2 lines are parallel, then alternate interior angles are congruent. So if I want to try to write my congruent statement, I have congruent sides, I have a pair of congruent angles, but my triangle is not right. So I still need 1 more thing. So looking at my picture, I know that DB is congruent to itself because of the reflexive property. So that actually gives me my 3rd piece of information. So I have 2 sides and I have an angle. So if I look, I have side angle, side, and then I have side, angle, side. So the congruence method used for this set of triangles would be side, angle, side. This is the same reasoning that you guys need to use when you look at your homework today, because this is kind of similar to what is going to be going down. So one thing I'm going to encourage you to do, and I've encouraged you all year long, is to look for key vocabulary words. So when I look here, I see the word bisects, so two equal sections. So DB cuts AC in half, so that means the E is a midpoint. So these two segments are congruent. My problem also tells me that DE and BE are congruent. So now I have two sets of congruent sides. I either need third side or I need a set of angles. So looking at this picture, if you are thinking back to example number 1, this is a classic example of vertical angles. So if I look at this picture, I have a set of vertical angles that are congruent. So I have two sets of congruent sides and the included angle, which is side, angle, side. Today on your homework, you will need to make sure that you list those congruent pieces if they are not listed in our congruent statement. So I have one piece of congruent information here. I'm going to need to list my other two pieces or my other two congruent statements. So I know that segment AE is congruent to segment EC. I also know that angle AED is congruent to angle BEC. And together, those three statements are what allows me to use side, angle, side. All right, so moving on to example D. Looks like we've got a lot of angles going on here, so let's see what they're telling us. So they're telling us that angle A is congruent to angle D. They're also telling us that angle B is congruent to angle E, which naturally means that angle C is congruent to angle F. If you write that down, you see the AAA battery. The AAA battery does not exist, which just means that it is not possible to show that these two triangles are congruent. I'm not telling you they're not congruent. They look pretty congruent, except we don't have that piece of information that will actually verify their congruence. Okay, so take a minute. I want you to hit pause, and I want you to work on E and F on your own, and then come back to me, and we will see how you did. All right, welcome back. Since you did these on your own, I'm going to go pretty quick. You have angle A is congruent to angle D. You have angle C is congruent to angle E. And we have that AC is congruent to DF. If you look at the location of this side, it is between this angle and this angle. I count the number of congruent signs I have, and I actually have 3 congruent sides. Since my side is between my two angles, this should have been angle, side, angle. All right, example F. AD is equal to BC, and BD is perpendicular to AC. So if I think, and I'm highlighting and I'm really focusing in on these important geometry symbols, they're always telling us something. Perpendicular lines form right angles. So I know that angle ADB is actually going to be congruent to angle CDB because they're both right angles. However, if I'm looking at the number of congruent statements in my problem, I have one here and I have one here. I don't have a hypotenuse, and I don't have a hypotenuse that's congruent, so I can't really use hypotenuse legs because I'm still missing information. So looking at this picture, I've got to come up with something else. And if you look at this picture, you could say that BD is congruent to itself, and that would give me piece number 3. Now you just have to determine the method. You have 2 congruent sides, so a congruent side and a congruent side, and here you have a congruent angle. That angle is between the 2 sides, so this would be side, angle, side. All right, so let's tackle the last 2 examples. I'm going to let you hit pause and work through them, and then you can rejoin me. All right, welcome back. you have angle ACD right here and angle ACB right here. They also tell us that AD is congruent to AB. Beautiful. So if I start counting, I have one congruent sign, two congruent sign. I am badly needing my third congruent sign. Reflexive property should literally be jumping out at you on these pictures by this point. So AC is congruent to AC. That's my third congruent sign. Whoops, need another hash here though. So now if I look at it, this angle that I gave you is actually not between the two sides. So this would be a classic example of ASS. And since we don't have any donkeys in this class, this is going to be not possible. And last but not least, angle A and angle C are right angles. So we have a right angle here. We have a right angle here. They tell us that segment AB and segment CB are congruent. It is just jumping out at me. I literally can't stand it that BD is congruent to BD by the reflexive property. And although this looks like angle side side, you could think of it as angle side side, but very special. This is a right angle, and a right angle is a big red flag, so I'll write it in red, that if your hypotenuses are congruent and one of your legs are congruent, that you can use hypotenuse leg. All right, today you have an assignment 5-6, and it says no donkeys or AAA batteries, and you are basically doing exactly what we were doing in the notes. Please make sure that you mark up your pictures and you write reasons why the separate parts are congruent, and I look forward to seeing you tomorrow in class. Have a wonderful, wonderful day.